Hey, what's up everyone? Murli here. Welcome back to the AWS Cloud Demo. So in today's demo, we will look into Kubernetes side of things, and we will deploy an example application into the AWS EKS, and we will talk about a lot on the Kubernetes. So please do subscribe to my channel. Please like this video. Before we head to our demo, I would strongly recommend please understand how Kubernetes works, because in this demo I'll purely focus on how we deploy a Kubernetes application into a AWS EKS. But I will touch base some of the key concepts in Kubernetes, something like containers, clusters, pods, and some of the services or deployments, this kind of stuff. So I will recommend you guys please go through the Kubernetes documentation, or please understand how Kubernetes works before you deploy into the AWS EKS. Otherwise, you will have tough time to understand how AWS EKS works. Okay, so let's begin discussing about Kubernetes. So what is Kubernetes? Kubernetes is an open source container orchestration platform, and it provides a way to automate the deployment, scaling, and management of containerized applications. So the main goal of Kubernetes is to simplify the management of containerized applications in the distributed computing world. Okay, so here are some of the key concepts that you should understand. So containers is nothing but your Docker containers that can be hosted into your Kubernetes pods. And what is a pod? Pod contains one or many containers. Okay, and cluster is nothing but which consists of a set of nodes that run containerized applications. For example, in our case, in AWS EKS, we will add the node groups, which is nothing but EC2 instances, which runs our pods, and pods runs our containers, right? So that is our cluster, and you can imagine that each node is a physical machine or a virtual machine. Okay, and coming to replication and scaling. So Kubernetes allows you to create multiple replicas of your application for improved reliability and scalability. If one application is down, one container is down, you can use another one to quickly make your application highly available. And it is all done by Kubernetes, so you don't have to worry about it. You just have to set the configuration for it, and that will take care of the rest. And it can automatically scale the number of replicas based on resource usage or custom metrics. We can see all of that. Okay, and coming to deployment, so Kubernetes provides a declarative way to manage application deployments. You can define the desired status in the YAML files. Okay, we will look into that shortly. And you can also do the configuration, secret management. You can also do the health monitorings, and integration and extensibility. There's a lot of stuff that you can do with it. So some of the use cases for using Kubernetes are like, you can as we discussed, you can use this Kubernetes for the microservices architecture, for scalability and high availability. You can easily roll the updates, and also you can do the rollbacks pretty quickly, and multi-cloud hybrid development. So you can deploy not just for AWS, you can also deploy it to the Azure or Google Cloud platform. So it's totally up to you which one you use, but in our example we will use AWS EKS. All right, so you can also use it DevOps, CI/CD, auto scaling like we discussed, and also for service discovery and load balancing. Load balancing is one of the key feature that you will see in our demo. Okay, so that's enough of discussion about the Kubernetes on a high level, and you should really understand how it works by going to the documentation. And I will try and explain how in this video, but I'll try to keep it short, because this video is not specifically on Kubernetes, but this video is specifically on how we deploy the your Kubernetes, your application into the AWS EKS. Okay, for that I've already pushed some of my images, like K8's front-end app auth users. So basically we will create a subscription app where the user will enter his user ID and password and subscribe to our application, and we will also see how it works. Okay, and if I go to the code base here, KS deploy, so you can go to this KS deploy. I will drop the link in the description box below. So you can see that this application has three different apps, which is auth, users, front-end app, and Kubernetes. We will talk about this a bit later, but and we also have Docker Compose. Basically we have created our applications into our Docker files. You can see, so each of our application is a Docker container, so we will run them in the containers. So this demo is basically which creates a pod to pod communication. We are not deploying everything inside one pod. So because I know one pod contains multiple containers, but we are using each pod for each container. For example, our front end app has its own pod, our auth API has its own pod, and our users API has its own pod, and we will see how pod to pod communication works. Okay, I'm also using the Nginx reverse proxy here, as you can see here, Nginx reverse proxy. So I will also explain what and how the Nginx proxy works. So please watch this video until the end so you will understand how everything works. Okay, don't skip the video. So this is our code base. Please check out this code base here, and then we have also used the MongoDB instance here. So we have used MongoDB to do the connection. So basically it's a full stack app where we have used the Next.js as our front end, we have used Node.js Express APIs as our backend, and also we have used MongoDB for our database. Okay, for this demo. So make sure you are using the right version of Node.js. Okay. Also, while building these images, you can see that these Docker files. So I've opened the Stackoverflow links where there are issues working with Mac M1 chips. Whoever is working on the latest MacBooks, so you should be able to add this in your Docker file so that this will work for you in AWS EKS. Okay, otherwise, trust me, you will have a tough time, because I had and I experienced. So that this will, this will save you a lot of time. Okay, so now let's move on to logged into my console already. Okay, so for this to work, what we're gonna do is we're gonna create our VPC. So I will add this link here in the description, so you can see how we create a VPC to create the AWS EKS cluster. Okay, just scroll down bottom and copy this link, which is this one, which creates our VPC for our AWS EKS cluster. Okay, go back to your console here. If you haven't logged in already, please log in and go to CloudFormation template. Okay, so now I'm clicking on CloudFormation and create stack. So click on create stack here, leave all these defaults and just paste the S3 URL that you have copied just now. Okay, and then click on next and enter the stack name, which is EKS VPC, and leave these defaults and click on next, and I think you are good to go. Let's go ahead and click on next. This is your review screen and everything looks good. Go ahead and click on submit. So this is going to create your EKS VPC cluster. So once it is ready, we are going to create our EKS cluster, okay, inside this EKS VPC. Okay, for that you also need a couple of IAM roles. Let's head to the IAM. Let's duplicate this tab here and go to IAM like so. And I have created two roles, which is EKS cluster role and EKS node group role. So for AWS EKS to create our cluster and talk to our EC2 nodes, we need to create this couple of roles where it can talk to the EC2 instances on our behalf. So for example, EKS node group. So we are assigning this node group to our group in AWS EKS in order to, it talks to the EC2 container registry, it talks to the EKS worker node policy and EKS CNI policy. So if you go back to roles, so I have chosen, let's type EKS again. So I have chosen EKS and then selected this cluster role. Cluster role is what it allows you to create our cluster, and that permissions, and node group is allows to talk to the EC2 instances. So you have to select EC2 for this particular EKS node group and select these policies, because just pause this video right here and copy these names and just add these policies to your EKS node group role. Okay, so once you're done with this, and go back to the roles, and also don't forget to create EKS cluster role of type EKS. So you should select EKS first and then add this policy, which is Amazon EKS cluster policy. Okay, you can read the description here what it does, and that should be able to help you. Okay, and also create this EKS cluster rule, don't forget that. So once you have your IAM roles ready and once you have your VPC ready, so it takes a couple of minutes to create this VPC. So what we're gonna do now is I'm heading over to my code base. Okay, so I'm gonna go to, so this is my code base, and I have three different applications: auth API, front-end API, front-end app, and Kubernetes and users API, right? So we will look into the architecture diagram, how everything works. So I head over to the draw.io. I will add this link into the description box below so that you will be able to understand how this works. Okay, so this is our VPC, private VPC, and this is our AWS EKS. And you see that different pods have different containers, which is React application, which is our front-end application, users API, which is another Node.js application, which talks to the MongoDB and gets the data and stores our user information, whatever we send from the front-end app, and talks to auth API. These are three different applications which are running in three different pods, and we will see how pod-to-pod communication works. Okay, so. And by the way, this is our EKS cluster, and we have also used Nginx reverse proxy in order to redirect our requests to our API, to our front-end app into our users API. We will see how it works in some time. Okay, so don't forget to watch this video until the end, and we will also see how we connect to the MongoDB. Okay, so first of all, head over to the MongoDB. Let's make sure some things works correctly. So go to GitHub and log in. I've used GitHub to log in to my account, and let me just log in to my account in MongoDB. Yeah, there you go. So basically, I have, so basically you land on this page, which is here on projects. Click on the project, and you see this is my users. So for example, let me click on browse collections. So you can see I have created a database which is a users, and it has all the users information, right? This is my previous users, so you can see all the users that I have previously created. So for this to work, in order to make this work, what you're gonna do is I have the users API. Let's go to the users.yaml file. So if you come to the users.yaml file, right, so what is happening here in these YAML files is you can see that this is our container, go/kh user. This is our container. Okay, and I have my MongoDB connection URL here, which is MongoDB plus SRV. So I will show you how this thing works. Okay, and you can see this is my whole MongoDB URL where I'm connecting to the users database. So the name is up to you, but make sure this exists in your MongoDB database. And you can see I've used my username, password here, and this is my cluster. So where do you get this connection string from? So if I go to here and overview and click on, so let me go back to the projects, and here, and you can see you can click on connect. When you click on connect, so expand this MongoDB deployment client. So you can see this is my MongoDB plus SRV. So you copy this URL and paste it in your console, and paste it in here like so, and then use the database that you wanted to connect. So make sure you have this connection string. By the time you watch this video, I will delete my MongoDB instance, so make sure this might not work. So make sure you have created yours. Okay, and that's pretty much connection. And auth service default is something that I will explain a bit later, because we will talk about how the whole thing works. Okay, so basically you can see we have deployments. There are different objects in Kubernetes. On a high level, deployments is something that deploys our pods into the containers in our Kubernetes world. Okay, so this is my deployment, and the replicas is nothing but the number of pods I want to create. So if I go back to the diagram here, you can see these are my pods. So I want to use only one pod. Okay, and also I'm creating a label called user, so that the particular pod can be selected by this app. And then if I scroll down a bit, and you can see this is my container, and you can see the users API is my container name, and this is the container Docker image that I'm trying to use, and this is my configuration for connecting to the MongoDB, etc. So if you have multiple containers in the same pod, then you will do something like this. You just do something like name, and you give the different container name and etc. Okay, so that's simple it is. Okay, to create a containers in the same pod, but if you want to create a pod in a different pods, then probably do only one container per pod. Okay, so this is our deployment which deploys our pod container. And what is this service? And service is nothing but which connects to our pod. So you can see the selector, right? So that is why that I've mentioned here, this is our selector name, and you use the selector name to connect to your users pod. Okay, and the type is load balancer because we want to access this application in the outside world. And also there are a couple of things you can also mention in type, which is cluster IP, which is nothing but connects to the internal pod for pod to pod communication. But in our case we are using load balancer, right? So let me revert back that change. So we want to use load balancer here, and my target port is nothing but my Docker container is running in 3000, but I want to connect and expose this particular service into in the port 8000. Okay, so we will use this port 8000 and connect to our user service. You remember this is our users.yaml file. We will connect to this user service from our front end app, and internally the users app also connect to our, for example, our auth.yaml file. So you can see again there is another deployment which is in a different pod, and this is our selector auth, and you can see this is the Docker image that I'm using to connect to the auth. Okay, it's auth. This is my Docker image which is connecting. Okay, and service is something that we have explained already. So we want to expose our users. We want to expose our auth API to the outside to our internal cluster. Okay, so whatever the pods is available, so pods can communicate with this auth API using this auth service. Okay, that is why I mentioned cluster IP. So this doesn't necessarily be accessed out in the outside world, so it's only available to the cluster. Okay, so that's why I have given cluster IP, and my Docker container is running on 3000, and I'll connect to the 3000 API. So why we had this first in place? Because we have our users YAML file which connects to our auth API internally, and which returns some tokens, based on the logged in user or based on the user subscribed. Okay, and let me go to the auth API. So if I go to auth API, or maybe let's go to users API and go to controllers, or maybe go to users action. So if I go here, right, so you can see auth IP address is my environment variable here. And if I go back to the users, so the auth IP address is nothing but our auth service default 1000, which is nothing but the core DNS name, so which allows you to connect to the auth service. The user service will be able to connect to the auth service by using this core DNS. This is called a domain name, which allows you to connect to your APIs which is running internally to the cluster. Okay, so I know this the terminology is a bit difficult to understand, but once you see the demo you'll understand the whole application, how it's working. Okay, so that is a overall view about the Kubernetes application, where you have deployments, where you have pods, where you have services to expose your pods to the outside world, and all that stuff. Okay, so I hope I made some sense. I hope this is clear. If you guys understand this, please give it a like, please subscribe to my channel, don't forget. So that's the Kubernetes world. Okay, and auth API is nothing but a simple Node.js application where you have the APIs and a simple express application, and we have our Docker file which builds our application and runs on port 3000. And for your information, I have added this platform Linux MD64 because I'm using Mac M1 chip. So because of which reason I had to add this, but in your case you might not need this if you are not using Mac M1 chip. Okay, so make that a point, and let's move on. So we have our app running. Okay, so first let's see how this thing works in our local before we deploy to the AWS EKS. Okay, so now open up your terminal and let me go to the let me go to the Kubernetes. Okay, you have your auth front end and users YAML files here. Okay, so what I'm going to do now is, let's see, I have used Minikube. So if you haven't installed Minikube yet, I would highly suggest to use Minikube and install the Minikube. I will put that links in the description box below. Okay, so I've already installed Minikube, so I won't walk you through any Minikube installation because I want you to do that on your own. And once you're ready with Minikube, so just hit some commands like Minikube dashboard. So this will open up our Kubernetes deployments. So this has opened somewhere here. Okay, this is how it looks, and there are no deployments yet, there are no pods yet, so there's it's nothing nothing new for us. And you can see there are no deployments yet. Okay, so what we will do is I'm gonna use a new one, new terminal window. Okay, so maybe, yeah, let's this dashboard keep running. So what I'm going to do is I'm going to create a, go to Kubernetes. Okay, and now what we will do is, I hope this window is clear. So first let's look into the configuration, how our local Kubernetes is going to talk to our AWS EKS, because so based on the config that we use, so we will be running it locally first, and then we will be pushing our local Kubernetes application into our AWS EKS. Okay, first let's look into the local one. So there is a file called, there is a folder called .kube in the root directory. So this is in Mac, but I'm not sure how where exactly this folder lies if in Windows, but make sure you have this folder in Windows, and go to your config. So I have two configs here, one is Minikube config and another one is a normal config. So Minikube config is specifically for Minikube. I had to rename this, but this one is specifically for the AWS EKS. So what we're gonna do is we will rename this to AWS. Okay, I'll show you how you can set up this. Okay, let me remove this first, and then also remove the Minikube. So this is how your default file looks like. You don't have config.minikube, they have refactored. So in the config that you see here is our basic config, which is for Minikube. Okay, so how we run Minikube application locally. So what is Minikube? Minikube is nothing but our cluster, which allows you to run worker nodes where you can deploy your containers and stuff like that. So how you run, so let's check the status of our Minikube. So let's see if this is running. So it is running. If it is not running in your case, simply run Minikube start. Okay, that will start running the Minikube. Okay, so once your Minikube is running, so what you're gonna do is you're gonna create a cluster. So once it is running, so what you're gonna do is we will open up, just clear this out, and now what we're gonna do is you will also have to install the kubectl, because kubectl is something that allows you to talk to the cluster that you have just created, right? So Minikube starts the cluster, and kubectl is something that you wanted to talk to the cluster and get things done. Okay, so kubectl will issue commands to our cluster, something like get deployments, kubectl get services, for running services. Okay, for currently there are two services running which are exposed, and then you can also expose these applications to the outside world using Minikube service and then the service name. Okay, so we will see how that works. So for example, in our case, what we're going to do is I will run this application locally, and then let's take it from there. Okay, so what we're going to do is kubectl apply -f auth YAML -f users YAML frontend YAML. Okay, so just hit run. So it is now created our services. You can see all the services are created. So if you want to make sure, what you're going to do is kubectl get services. You can see what are the services running. So you can see these are pending. So don't worry, your load balancer is not going to be created locally, so that's why it shows as pending. So don't worry about that. And let's minimize this a bit for a better view. Okay, that looks much better. And now you're gonna see deployments that has happened, get deployments, and there are three deployments which are auth deployment, front-end deployment, and users deployment. You can see these are all running locally, and auth deployment is nothing but our auth YAML file, which runs our auth API, which has our Docker file, so it is running our containers. Okay, so what we're gonna do is now we want to expose our services. How are you gonna expose our services? So kubectl get services. Okay, so these are our services which are running as we discussed. Now front end service, copy this front end service, and we want to expose this, right? Minikube service and front end service. Let's okay, there you go. Our application is running inside our Kubernetes cluster. So what I'm going to do is right click, open up, inspect, and click on network. So refresh a couple of times because some of the services might not start immediately, so you're going to wait for some time. So let me register my name to 3 at cloud.com. We don't own this domain, so just remove that. Prashant.me, that's my email ID, and I'm gonna enter the password something like this. Okay, make sure you have. Okay, and now I've entered my password and entered my email address, and click on subscribe. Okay, there you go, you're now subscribed. So basically our API returned success. So as you can see, our application is running on 62812 as like here, but it is actually going to our users API. And how it works, because basically we have used a trick called nginx. So our nginx looks for this. What Kubernetes does is, so it looks for this user service default 8000, because this is where this is the core domain address that our Kubernetes runs our user service inside our cluster, and which is known to the Kubernetes. So that's why when it looks into this, it replaces this with the actual domain. So whenever I hit /API like this, /API/signup, so it looks for the /API and redirects to the user service. So that's how it is going to the user service, and that's how it is hitting the user service API, and in turn it is actually calling the auth API and making a MongoDB request and storing our subscriptions. Okay, so that's how the nginx is playing a reverse proxy role here. Okay, so for to understand reverse proxy is nothing but, it's nothing but running your application and connecting various different applications into one domain, and you just redirect them to the based on the URL request, you just redirect to the particular applications. In our case, we have redirected to the user service. Okay, it's just that's what a reverse proxy does. It runs multiple applications on the same domain. That's it. So our application is nicely working in our local, and you can see you got the response from our Node.js application, and back to the front end applications, right? So everything works perfectly fine, and let's go back to our terminal and just hit Control C to exit out of the interactive mode. And now what I'm going to do is I'm going to run the same command again, and this time I'm going to delete the entire cluster. I'm going to delete entire running pods. Okay, so delete, just delete it, and everything got deleted. And if you go back to your Kubernetes and refresh it, there is nothing right now. Okay, so if you want to see how pods and services run here, you're just gonna do again, just to show you how it works. So come here and refresh this page. You can now see there are 3 pending deployments going on, and pods and replica sets there's nothing, and you can see that all our pods and services are running, and you can see these services which are running. As I told you, this will be in pending state because there will be no load balancer created locally. Okay, so that is our Kubernetes deployment locally. And now what we're gonna do is we will run something locally. Okay, now that we have seen how our application in local Kubernetes and in Minikube, how we deploy our application and how we run our application, and we have also talked about the Nginx proxy and how we set up things and how we redirect based on the requests. So what I'm going to do is now I'm going to deploy our application into AWS EKS. So for that, let's go head back to the cluster that we have created previously, sorry, the VPC that we have created. Now that our VPC is ready to be used, and also as I've discussed, please make sure you create the IAM roles that I've created previously. And now let's head back to the EKS Elastic Kubernetes Service and create on cluster. Okay, so now we are on the configure cluster. So what I'm going to do is subscription app. So basically this is a subscription app. I want to choose the version which is latest 1.26, and this role is pre-selected because I've created this role. As I said, please go ahead and pause the video where I have discussed about this IAM role, create this role and select the EKS cluster role here. Okay, and click on next. And here in VPC, you remember we have just created our VPC, which is EKS VPC. Select that EKS VPC and select the subnets automatically selected, and ignore about the security groups over here, and also select the public and private cluster endpoint access, because you need the cluster endpoint is accessible from outside your VPC. Okay, so that's why I have selected public and private. In our application, we have our private and public APIs that we want to connect outside or inside the cluster. Okay, so that's why select public and private and click on next, and leave all these defaults and click on next. And it sets up the core DNS, which that's how you're able to find your APIs inside the cluster. You're also using the kube proxy, and click on next. So leave these defaults and click on next, and scroll all the way to the bottom and go ahead and click create the cluster. So once your cluster is ready, so what we're going to do is we will also need to create the node groups. As I said, cluster is something, it's a cluster where you save where you need to deploy your worker nodes. So EKS cluster won't create everything for you. You just have to add the node groups. So if you go to compute tab, you will be able to add the node groups to your cluster, so that you will be able to deploy your application inside the node group. That means essentially it's a, once you add the node group, it creates a EC2 instances, and you when you run kubectl apply, so what it does is it applies the configuration and runs your containers inside your EC2 instances, inside your pods and containers. Okay, so that's how it works. So let's wait for this to complete. If you click on clusters and refresh a couple of times, it takes a few minutes or a couple of minutes, or maybe it takes some time to create your cluster. And once it is ready, what we will do is we will do a bit of configuration. So actually what you can do right now is go to IAM, or maybe go to your user, click on security credentials, and if I scroll down a bit, right, so you'll need to create access keys for you. So once you have access keys, you'll have to run AWS configure, something like this. So and then you will paste your access key and your password, so that your application will be able to recognize which user is making this request and which account and what is your region, default region, and all that stuff. Okay, so once you have configured a user into your AWS configure, then what you're going to do is we will run a command where how does a AWS EKS know that you want to deploy this application into it. So we will write a command which is AWS EKS, okay, and then specify the region, your default region, which in my case it is US East 1, and then also do update kubeconfig. So we are going to use the update kubeconfig like I've discussed, right? So just hit Control C here. Like I've discussed, I've not entered this command yet. Okay, I've just exited out of it. I'll show you how this works. So as I said, open up your kubeconfig, which is this. Okay, so take a copy of it, just duplicate this file, okay, and rename this to your local config, which is config.minikube. So this is your local minikube config. Okay, and when you run this command AWS EKS update-config, for example, let's copy this command again. Okay, and clear this out, paste this command again. Okay, so what you're telling to AWS EKS is use this configuration. Okay, use this configuration that we are just about to write, and update this config file, so that when you run kubectl apply command, so it will, instead of creating your local deployments, it will go ahead and use this AWS EKS cluster, and then it will deploy your apps inside the AWS EKS instead of local application, local minikube. Okay, so what is the cluster that you want to deploy, which is subscription app, right? So let's confirm the name again. This is our cluster. So this is where I would like to deploy my applications, right? So I'm going to update the config, my local config. So once this the status is still creating, the cluster is creating, as you can see, it is still creating. We will come back again to this once the cluster is created. All right. Okay, looks like our cluster is now created, and I think we are good to go. So please make a note. So if you want to run this in your local, in your AWS EKS, so make sure this if you want to avoid any costs, then you might not need to do this, because this will incur costs, and it will take a couple of dollars or $3 for you to run this particular application. So make sure that you don't create this if you don't want to, incur costs. So if you have a couple of dollars, then go ahead with this, give a try on AWS EKS, or just watch the demo and learn how it works. Okay, and if you have if your office provides you any AWS accounts, and that's where you can go ahead and create this. Otherwise it will incur costs. Okay, so I just want to strongly advise, stay back if you don't want to spend money on this. Okay, so now that I have created a cluster and click on our cluster is ready. Okay, and now click on compute. So we do not have any node groups yet, so this cluster is empty without a node groups. Okay, so what I'm going to do is click on add node group, and I'm going to say EKS node group. Okay, and select the node IAM role, and I have, as discussed, I have created EKS node group role, where it will allow the EKS to talk to the EC2 instances, and on your behalf. So give that permission to your EKS node groups, and then scroll down and click on next, and make sure it is Amazon Linux on demand instance type. So here in instance type, I would recommend you use the small instance, because you need at least 2 vCPUs and 2 gigs of memory for it. Okay, so select the t3 dot small, and leave the disk size as 20. You don't need more than that, and I'm giving 2 nodes. Okay, so that means it creates a 2 EC2 instances, and click on next. Leave the subnet selected, configure the remote access to these nodes. If you allow this, right, so there's a little warning here, I will rather allow EKS to handle, and I don't want to allow any remote access to my nodes. Okay, I will allow EKS to handle my nodes for me, and click on next, and that's it. It's pretty much, we have selected all the configuration that we want, and click on create. All right, so now that we have created our node group, so it takes a couple of minutes. Okay, and go to your cluster, click on compute. It will add your node group. Okay, so just refresh a couple of times, you should be able to get your node groups. So that means it will create EC2. So let's open up EC2 in a new window. Okay, and also let's go to instances running. So there are no instances yet, so you're going to wait for a couple of minutes, and that will create instances for you. And refresh a couple of times. So it's still creating, so let's wait for it, and once it is done, you will be able to see the instances which is running in local. Okay, and previously we have run this command, which is AWS EKS region update kubeconfig. So we basically updated our kubeconfig locally. So that means now my local application knows when I run kubectl apply and apply the Kubernetes, then it knows where to deploy this application. So let's update this config again. Let's see, the cluster is already created, so this should now be able to add a new context, which is this in my case, and you can see the kube config has been updated. Okay, so now it is ready. So what I'm going to do, let's wait for this EC2 instances. So now you can see a couple of EC2 instances are running, and go back to your node group and refresh it. Let's see. Yeah, it is still creating, but looks like it is already created. Okay, just give it a couple of minutes more in order to make sure our node groups are fully up and running. So there you go, there are two instances which is running. So you can see this is not yet ready. So let's wait for the status to finish complete creating this node group. So just to make sure that we don't mess with it. So as we can see, now my node group is also active, and I have my EC2 instances which are running. So that means now I can go ahead and deploy my Kubernetes application into the AWS EKS. So all that I'm doing is switch to this folder Kubernetes, and then just run the kubectl apply -f auth user and frontend YAML file. Just hit enter. So it's going to create our applications inside our Kubernetes AWS EKS. So you can see the status by typing kubectl get deployments. Okay, so you can see now the deployments are ready. So you can see it's ready. All three applications are running in my AWS EKS, and also get the kubectl get pods. So you can also see if pods are running. So you can see the pods are running, which is great. And also kubectl get services. Oops. So you can see all my pods are running and all my services are also running, and we have created a load balancer. So as like I said, so locally you will not able to create the load balancer, but in AWS EKS when you launch this application, so if you go to EC2 instances again and click on load balance on the left side, so it will create the load balancers for us. So where you will be able to access your applications which are hosted using the Kubernetes. Okay, so going back to the terminal, so you can see our front-end service or auth service and user service, everything is up and running. So what I'm going to do is I can copy this URL, which is this one, copy the load balancer URL, and which is exposed on port 80. So that means you do not need to add any port number after your it is running on default HTTP. So open up this page and close this one and open up the load balancer. You should be able to access your application in a minute. So there you go, your application is now running on this particular load balancer. And what I'm going to do is I'm going to open up so hang on a second. So inspect, and now click on network. So let all the services run remotely in our EC2 instances. So what I'm going to do is kubectl, I'm going to do kubectl pods one more time. For example, you might have some errors while running this containers. You might get something like crashed or some other status. So make sure your Docker container, there are only two possible errors. One is the Docker container which was not able to run because of you might be using from Mac M1, or you might be creating something else which might not run sometimes. As we discussed, you'll need to add the platform tag in your Docker file, or make sure your Docker file is running, make sure your Kubernetes is running locally, and then deploy to the AWS EKS would be an ideal preference. Okay, so now in my case everything is running. In case if your pods are not running, or if something is gone wrong in status, how do you check it? So basically I can copy this. Okay, copy the pod name, and what I'm going to do is kubectl logs the pod name. So enter. So you can see all the logs which are coming from my front end service pod. So also you can see, you can do the same thing with other pods like user service or auth API. So let's paste the logs from here, kubectl logs, and then this one. So you can also see there is no logs from this one because everything was successful, so I don't have any logs over here. So let's I hope you understand how this kubectl works, and how you can debug your pods or containers or applications, right? So if you like it, please don't forget to like this video. Okay, and head back to the application where you have deployed in your load balancer, clear this out, and my application is ready. So I'm just trying to hit the API, which is, I'm gonna register my application, which is gomurli 4 at the rate blah blah blah.com, and I'm gonna hit I'm gonna choose a password. Okay, and then clear this out and subscribe. So there's something undefined. A request failed with the status code 500. So we have some error in place. Subscribe again. This sometimes takes some a while to create this application. So there you go, it is now worked, because it takes a while to spin up all the services, and your nginx config redirecting to the API. So you can see it is going to the load balancer, this same front end application load balancer, but it is redirecting to the users API, right? And now your application is working, and you can see the response, and you can also see the data that is getting back. So your application is fully working, which is deployed into the AWS EKS. Okay, I hope you enjoyed this video. Please don't forget to like, please don't forget to subscribe. If you have any questions or anything that you want to learn or something, please put down in the comment section below, so that I will be able to create and create some very good content. Okay, so now it's done. So you're pretty much created. So what we're gonna do is, we have completely set up our cluster and everything inside our VPC. So what I'm going to do is, now it is the time to tear down all the services that we have just created. Okay, for that, what I'm going to do is just go to clusters. As soon as your testing is done, as soon as you learn something, what you're going to do is, the best idea is to, tear down all your services which is running. Otherwise, as I said, you will incur a lot of costs. So first step is to select your class cluster, go to node groups, select your node group, and delete your node group. Okay, click on delete, and it takes a while to delete all your node groups. That means you're essentially deleting all your EC2 instances. So all your EC2 instances will be terminated in a second. So just give it a second, and once it is done, you will be deleting your cluster as well. Okay, looks like your node group has been deleted right now. And let's go back to the clusters and select the cluster that you have just created and delete it. Okay, and copy the subscription app and delete it. Okay, so it's gonna take a while to delete your cluster. Okay, so what I'm gonna do is, I'm gonna go back to my CloudFormation stack. Okay, and select the stack and delete it. Okay, make sure you delete this stack as well. Click on the cache. So there you go, now the delete is in progress. So once you have deleted this, I think you're good to go, because you have deleted your cluster, node groups, and your EKS VPC. So you're all set to go. So thank you so much for watching this video, and please don't forget to subscribe to my channel. Please like this video. I really this gives me a lot of motivation to make more videos. Please do subscribe it, and thank you so much. I will see you guys in the next video.